Okay, now we're going to capture the actual truss profiles. I usually take a yellow pad, mark all sheets so that we don't get them confused, because again, after 6 or 10 jobs in 4, 5, 6, 7, 8 days, lots of pieces of paper, lots of photos can get very confused. So this is going to be the truss profile. So before I get up the ladder, I start with a sketch of what I think the truss is going to look like. And I'm standing here with my back to the front of the building, and I'm anticipating seeing a truss that's sloping down and to the left. So I'm actually going to draw that in here just like this. I expect to see a truss that's going to look like that. I'm going to go ahead and draw my wall. Okay. I'm going to measure on the inside of the store from face to face a wall. And in this particular case, we came up with 28 foot 6 inches inside. Face a wall to face a wall. Now, interestingly, notice we had 28 foot 6 inches on the inside, whereas on top of the roof, we had 28 foot 9. That illustrates the difference between the walls above and the walls below. Okay, so we like to record all of that data. Now, I pop my ladder up right here. The first thing I want to get is the truss profile. Normally, all these trusses are going to be the same, so visually verify they're all the same. If there's substantially different, if the doubles are substantially different than the singles, then we'll need a truss profile of both of them, okay? But normally they're going to be the same, and the doubles are simply doubled up together. Now, first thing we want to capture is the truss profile. And the way we approach that, I like to approach that, is this. We start with counting the bottom chord panel points. The panel point is where the vertical and or diagonal webs join to the bottom chord. Normally, the bottom chord panel points will be equally spaced across the entire truss, plus or minus a couple of inches. 85% of the trusses are equally spaced. Some of them they're not. But if you can get up there and visually verify those bottom chord panel points appear to be equally spaced, that's adequate for this particular step. So in this particular case, we saw there were between the walls 3 panel points, and they appeared to be equally spaced, okay? So I'm just going to note that here. When I'm standing on top of the ladder, I see one basically halfway, and then half of the half, I see another one and another one. I just make a tick there. Now, standing on the ladder here, I can plainly see there's a vertical here, so I draw it in, and a diagonal here. Now, this is a little bit of a different configuration. Usually there's a vertical there, but in this case, they have 2 diagonals coming from each of these that meet approximately in the midpoint up here. So I'm just going to sketch that in. Again, I'm standing on the top of the ladder and doing this. And I can observe over here and see it follows a similar pattern on this side. And like that. Now this building is a little bit narrow, 28 foot 6. You can often see sufficiently to the other side if the area between the trusses is unobstructed and the building is only 28 foot wide. Once you get a building that's 32 feet or 40 feet or 38, 35 feet wide, it's almost impossible to see to the other side. And for sure, you're going to have to move your ladder. Okay, the next most important dimension here is the depth of the truss. Now, we've discussed elsewhere in a handout that when you have a single slope truss, to get the actual slope of that truss, to get the depths accurately and the slope, we're going to need 2 different depth measurements at 2 different locations. So I'm here right now on my ladder. I'm going to go ahead and put my tape measure on the top edge of the top chord and measure down to the bottom edge of the bottom chord. Okay, we call that out to out. In other words, from the top of the top cord to the bottom of the bottom cord. If you measure anything different, like for example, from the bottom of the top cord to the bottom of the bottom cord, notate it. So always notate on these dimensions just what it is. Out to out means from the outside edge on the top to the outside edge on the bottom. In this particular case, we measure 34.5 inches. And where we had placed the tape, I looked down below the ceiling, put my laser up against that wall, and measured it at 11 foot 6 inches. Okay, we're going to have to get a second similar dimension and location on the other side, which we'll do when we get there. Okay, the next thing I want to do is notice the member sizes here. So we note it like this. Here's your top cord, here's your web, and here's your bottom cord. I can physically observe, and if I'm not certain, I'll put my tape measure on it, and I can see that's a 2x6. Bottom cord's a 2x6, and the webs appear to be all 2x4s. This is very, very common. 90% of the wood trusses you see are going to have this type of configuration. Sometimes they'll all be 2x4s, maybe 5% of them. Some will have a 2x8 in either the bottom or the top or both, either or. And that's maybe, 3 or 4%. So that's pretty standard what you're going to see. Okay. Sometimes the end web may be a 2x6 and all the rest 2x4s. So it's the cords that are most important. 2x4s, if they all appear to be 2x4s, noted as 2x4s unless noted otherwise. And if you see a 2x6 there, just note on here 2x6. Okay. Now, what's really important is to get the lumber grade. This can be difficult, but it looks like an ink stamp on the side of these boards. It almost looks like a tattoo. Different manufacturers will have their own different kind of logo and their own stylized way of doing it. Some of the older trusses, you can't even find the stamp, or you may find it not on the truss you're looking, but if you stand there and you look to the trusses a few feet away, maybe you're looking at the double and you can't see anything, but you look back here and over here you can see a wood grade. Noted. It's very important. The wood grades are tough to get, but they're almost the most important thing to get. Okay, depth's probably most important, but this wood grade's very important. Or maybe you see over here a stamp on the bottom cord and here a stamp on the web. Okay, if the trusses all look the same, then we can assume they are the same. We will assume they are the same and notate the lumber grades that you see, okay? In this particular case, this one said MSR 2400 SPIB. And we were able to see on a web SYP. Please note exactly what you see. And it's good to take a photo. Sometimes you can't figure out what these are, but if you can get a good photo, we can go back and research our records and often discern what these are. So this is very important to get these lumber grades as best you can. In this particular store, we could not find anything for the top cord. But to give you an order of importance, the bottom cord is the single most important grade. Top cord is semi-important, it's important, but not as important as this. The web is important. Okay, very good. Now, the next thing we're going to do is look for the splices. The splice is what is used to join the long cords together. These webs are often only 3 feet long or 5 feet long or 6 or 8 feet, which are lumber lengths readily obtainable by a truss yard. But in this case, that bottom cord is 28 foot 6 plus a foot. It's probably 30 feet long, okay? You can't buy a 30-foot long piece of lumber. You're going to buy a 16-foot and a 14-foot and splice them together, or a bunch of 8-footers or something like that. That splice at the bottom cord is the single most important connection in the whole truss. Splice on the top chord is important, but not as critical. The reason is because the top chord is pressing together, and even without a splice, they're going to sort of hold each other in place. But on that bottom chord, they're pulling apart, and the only thing that's holding that truss together is that splice. Okay, so we want to locate the splice, and in this particular case, we saw a splice right here, okay? And it was a plate. We're going to note it as SP, splice. We're going to measure it as 8 by 8. And these plates, all these can be within an inch, okay, within an inch. The more you look at them, the more you're going to be able to determine what they are pretty readily. Okay, now what's interesting here, it's an 8 by 8 plate on a 2 by 6 cord. So the plate is 8 inches high, but the cord is only 5.5 inches high. So that plate is sticking above the cord. And we notice that there's a 2 by 4 block on top of that cord. Okay, so we're going to say 2 by 4 block, 8 by 8 splice plate. Splices are discussed more in that handout. But what this means is they needed more steel than they were able to get on that wood. So they had to add wood to make the splice work. Again, splices are very important. On this also, we looked along the top cord and we saw a splice about mid-span here. And that was a 6 by 5 plate. Now, the rule of thumb for noting these plates is always show the horizontal dimension first and the height second. So 6 by 5 means 6 inches this way and 5 inches that way. And then try to draw your little illustration too, so it makes it clear 6 inches is the horizontal dimension, 5 is the height. Square, of course, is the same both ways, okay? Now, we're going to get the other plates. This one we measure to be a 14 by 10. Okay, this one we couldn't see because it was buried in the wall. All we could see was that it was 8 inches high. So we just go, it's something by 8. But the rest of it was sticking to the wall. We couldn't see it. Okay, then this one we saw as a square 6 by 6. And this one we saw as a square 4 by 4. Okay, now at this point, we took the ladder down, went to the other side, went up through the ladder here, and did the same thing. We noticed here, measured this to be 12 by 10. This one to be tall and skinny like that, and it was 2 by 4. This one we saw to be 6 by 4. This one was a something by 8. And then we still had to get our other dimension here. So we put the tape measure up here, and at this dimension, 11 foot 1 inches, we measured it to be 32.5 inches out to out. This is now our dining truss profile. We've got the profile, that is the position of all the diagonals. We've got the depths necessary to calculate that slope. We've got the member sizes. We've got the lumber grades. We've got the splices and their locations. We have the plate sizes. We have the interior dimension. And this one's done.